Hey there, in this video I want to talk about a certain type of matrix equation, and that's the kind of matrix called a tridiagonal matrix. I've typed an example of a tridiagonal matrix equation up here, and the blanks up here in the top right and the bottom left are meant to all be zeros. It's a convention to leave out those zeros to make it look a lot cleaner. And in many ways this is just a regular matrix equation, and we could easily solve this using the solve method. The thing is, suppose our matrix wasn't 5 by 5, but instead 1,000 by 1,000, or 10,000 by 10,000. At some point, the solve method that we've learned about isn't going to work very well. It's going to take too long. It's going to take too much RAM. There's just too many numbers for your computer to crunch all at once. We can buy ourselves a few more orders of magnitude if we know that we are working with a special case where most of the elements in the matrix are 0. And these are not all that uncommon in physics. This can represent like neighboring points along some kind of line where the behavior of any given point only depends on its neighbors. So if you think about Gaussian elimination, if you knew you were going to have a lot of zeros in that Gaussian elimination, you could make your code a lot simpler. So like if you knew you always just had this diagonal term and its two neighbors, the tridiagonal case, you could write a new equation solver that was a lot simpler, used a lot less RAM in your computer, ran faster. A more general case of these tridiagonal matrices is a banded matrix, where you have not just the diagonal and its neighbors, but maybe you have several neighbors. But you still have all zeros in the top right, all zeros in the bottom left, so it's still more efficient, just maybe not quite as much as the tridiagonal case. These have a built-in solver in SciPy called solve banded. I'm going to show you how to use that. The syntax is a little unusual, but the advantage of using solve banded is for gigantic matrices that are banded, it will work, whereas if you try to use solve with something that's got like 10,000 elements in it, your computer might run out of RAM. And even if it doesn't run out of RAM at 10,000, it certainly would at 100,000. So let's look at how solve banded works. I've already imported scipy.linalg as linalg. I type out solve banded, shift tab to see the documentation. Looking for a few things. L and U here are the number of rows above and below the diagonal. The assumption is you always have the diagonal. And in our case here, we'd have one above and one below. AB here is this matrix in a diagonal form, so sort of tilt your head sideways, and I'll show you how to type that out. That's kind of the trickiest part. And then B is this matrix over here on the right. This is for solving the equation AX equals B. Okay, so I already said here that lower and upper, that's going to be 1 and 1. It's expecting like a tuple or a list for that. And then we need to give it two matrices. Let's call the big one D for diagonal, and we'll call the little one V, because that's usually what we call it. So I need to define my matrices for D and V, and I'll use arrays for these. V is the easy one. That's no different than it normally would be. We can just type out the array 1, 0, 0, 0, 0. And D is going to be a two-dimensional array, so I'm going to make it out of a 2D list. Get the spacing looking nice here. Okay, it's going to have 3 rows in it, 1, 2, 3, corresponding to these diagonals here. So at the top, we're going to have -6, -6, -6, -6. Same thing at the bottom. And then the diagonal 2, 8, 8, 8, 2. Now, if I try to run this as is, it's not going to work for me. And the issue is there's only 4 things in the top, 4 things in the bottom, but there's 5 in the middle. And NumPy does not like having two-dimensional arrays that are not rectangles. So we have to add a 5th element to the top and the bottom. That's kind of the tricky thing here. Now if we look at solve banded, how do they want us to solve it? You can see here, this is their example where they had 1 row above and 2 rows below. But they've got this little asterisk here, which is kind of a little bit misleading. You don't actually want to type that out. That'll make your program crash. What it means is it's going to ignore what you type there. You can type any number at all, but you do need to have a number. Typically what you would do is type a 0. So we have to start this first row with a 0. We have to end the last row with a 0, or really any number, but usually a 0. And now we should be able to run solve banded, and we get as an array our solution.